today I will present a mathematical model about the evolution dynamic of heterogeneous tumor growth in its local environment. In fact, in my work, I focus on studying the growth of cancerous tumor, how it starts from a genetic change in certain normal cell leads to emergence of cancer cell. And after a sequential cell division, the tumor is formed, and that's depending on the local environment which surrounded the tumor and the genotype of tumor cell and its different cellular behavior. Also, in my work, I focus on studying a different treatment strategy for studying how cancer can be prevented. And as a first step, the main objective of this model is studying the impact of the local environment on the rapidity of tumor growth in combination with the cell heterogeneity concept. So we take into account the importance of cancer stem cell hypothesis, and we consider that tumor consists of heterogeneous population of cancer stem cell and cancer non-stem cell. We will start with a brief introduction and biological background. Tumor development passed through several stages. First, it starts with a small number of cancer stem cells, which compute in the same environment with the proliferation and migration, with limitation of nutrient and space. Then the vascular tumor passed through angiogenesis to its vascular stage after reproviding with nutrient. Then a certain type of cell escape from the main tumor to form metastatic through invasion. And in this model, we focus on a vascular stage of tumor growth, and we consider that there are three dynamics that cover tumor evolution. The first one is single cell dynamic for describing the life cycle of cell, the phenotype of tumor cell, how the neural network take the decision of the phenotype, and how the mutation impact the chosen phenotype. Also, the heterogeneous population of with different biological feathers. The second dynamic is cell interaction dynamic for describing cell movement in the space and how the type of neighborhood impact this movement. The third dynamic is cell's microenvironment dynamic for describing how tumor cells react with the local environment and its concentration of nutrient, oxygen, glucose, the extracellular matrix density, the enzymes, and the heterogen via reaction division equation. And we consider a cellular automaton model which combine and link all these three dynamics together. Now we will present the tumor growth model. We consider a cellular automaton model which considered as a grid with certain size, and each lattice may be occupied with tumor cell, and it could be empty and have local concentration of chemical of the chemicals. And tumor cell in the grid move and migrate in random way. So in the case of proliferation, one of the total cells shows a random adjacent lattice, and in the case of migration, we calculate the probability of movement, taking into account that movement probability is impacted by division part, the region with high extracellular matrix density, and the region with high oxygen concentration. In the same way, we calculate the probability movement to the one of adjacent neighborhood lattice. With consideration of heterogeneous tumor, we consider that there are two types of cells: cancer stem cells, which are immortal cells and have unlimited capacity of proliferation, and it may divide symmetrically or asymmetrically with certain probability. On the other hand, cancer non-stem cells may die due to natural mortality, to be an apoptotic cell with certain probability, and it may divide at limited time. And it have a limited capacity of division, and with this capacity reached to zero, the cell becomes quiescent cell. For determining the phenotype of cell, we consider an artificial neural network, which is considered as one of machine learning techniques. The neural network takes the information from the surrounding environment, such as the nutrient, the number of neighboring, the density, and pass this information through a layer of genes. Then the neural network determines the phenotype of the cell, proliferating cell or quiescent cell. We calculate the node in the hidden and the output layer with this formula, and we use a transfer function to ensure that the node's value is between 0 and 1. The impact of mutation is appear at this level by changing the weight matrix that links the layers together, and therefore impact the decision of the neural network. We follow the fate of each cell by following its life cycle, so we can see according to the cell type, cancer non-stem cell may die due to natural mortality or apoptosis. Then, if not, cancer cell react to the environment, so if there are insufficient nutrients, it will die due to necrosis. If the cancer cell is survived from death, then the neural network will decide the phenotype of the cell. Proliferating cells will divide according to its type, like we explained before, while quiescent cell will see if there are movement activation, then it will migrate to adjacent place. We consider that tumor cell react to the local environment via reaction division equation. We consider the following system of reaction division equation. So the first one describes the degradation of the extracellular matrix. The second describes the production of the enzyme which degrade the extracellular matrix by tumor cell and how it diffuses on the space. The third and fourth one describe how tumor cell react with the nutrient, oxygen and glucose. So it produced by the tissues, uptake by tumor cell and diffuse on the space. As well the heterogen which produced by tumor cell and diffuse on the space. Now we will move to show the numerical simulation and the result which were performed on the software Python. As we focus on studying the impact of the environment on the rapidity of tumor growth, so we determine the growth. We start the simulation with 4 cancer stem cells, and we determine the growth rate and the time when the tumor reaches its maximum size. We focus on studying the impact of oxygen and the extracellular matrix, and we determine the growth rate and the rapidity of tumor growth. Like you can see in the following figure that the availability of more oxygen and less extracellular matrix density make the tumor have a greater growth rate and, like shown in figure A, and grow faster and faster way compared to the environment which had low oxygen concentration and high extracellular matrix density. Also, from the following evolution curve of the total number of cells over the time, we can see in the environment which is rich with oxygen, shown in red line, that the tumor reach faster to its maximum size than the environment which is poor with oxygen concentration, which shown in blue line. Also, we can see that the environmental condition impact the morphology of tumor growth. In the figure ABC, the environment which is rich with oxygen, we can see that the majority of tumor consists of its quiescent cell, which shown in green color, and it grows in more compact way. While in the other figures, the environment which poor with oxygen and have a low density, the necrosis score consists the majority of tumor, and it takes more time to reach its maximum size. Also, for studying the impact of the heterogeneity on tumor growth, we change the value of probability of mutation and the symmetric division, and we determine the growth rate and the rapidity of tumor growth. So we can see the relation between increasing the number of cancer stem cells by increasing the probability of symmetric division and the rapidity of tumor growth. In the same way, from the following figure, we can see that in the environment which is poor with oxygen, tumor take about 400 days to reach its maximum size. While when increasing the probability of mutation and the probability of symmetric division, which shown in blue, the tumor reaches its maximum size in about 225 days. So the main result here that increasing the number of mutated cells and cancer stem cells make the tumor more aggressive and overcome the condition which prevent its growth. We will end with the conclusion and perspective. So we have presented a cellular automaton model for studying the evolution of a heterogeneous solid tumor growth in a variable chemical environment. We conclude that we can't ignore the concept of heterogeneity by cancer stem cell, which have the ability to generate a more aggressive tumor. As a future work, this model could be developed for modeling in angiogenesis coupled with lymphogenesis in combination with the hypothesis of heterogeneous tumor, so we can study the impact of and the lymphatic network. Thanks for